Okay, hello everyone. Nice to see you here again on our 70th meeting already in Krakow. Today we've got 2 presentations and 3 speakers. So we will start with presentation from PMI, from Patryk and Łukasz. Big applause for them. Yeah, I know it's hard even you're eating pizza, but thanks for trying. So they will tell us about how they created the system inside of the PMI to bootstrap applications and the whole infrastructure based on templates and a lot of AWS stuff, so the things we are probably here for. And then we will have Dmitry, which is working for AWS Professional Services, and he will be going through AWS networking from the basics to the more complicated stuff. And that will be pretty informational because most of the time I saw in most of companies that just enabling 000 IP is working for everyone. So why do you even care? But it's not a good practice. And I won't be boring you anymore. I'm giving the mic back to guys here. Take your sign.
Thank you very much. So where's the clicker? Okay, here. I guess we can move to our first slide. So effective, quick, and user-friendly application infrastructure bootstrapping at PMI. We'll talk today together with Patryk, first time on the stage. Few words and I believe interesting demo about our engine that we built. We integrated with our company portal, and thanks to it, we are able to ship some applications and good patterns to our internal customers quite quickly and effectively. So few words about us. My name is Łukasz Ożóg. I'm engineering lead in PMI, and I joined the company in 2016. So yeah, I'm responsible on daily basis for a team of engineers, and we are building, maintaining this engine and also the templates that we put on top of it. So that's me in short. Patryk, go ahead.
Okay, so my name is Patryk, as you can clearly see. I'm a DevOps engineer in Engineering Excellence Bootstrapping team. I've been a member of this team basically from February 2022 because I was hired directly, at the very beginning of E&E team forming. And on daily basis, I'm trying to make PMI colleagues' lives easier by hopefully, yeah, that's a good one, by delivering them templates, Jenkins shared libraries, providing some standards, guidelines, and basically, for example, some common Docker images, right? So that's it from my side. Voice back to you, Łukasz.
Cool. Thank you very much. So what are we going to talk today in details? DevOps practices at PMI. I want to say a few words about the scale and context of the situation. If some of you maybe were in 60-second AWS meetup, we had also presentation very much connected to what I'm going to show today. It was about templates as well, but we weren't at this stage of evolution. Today we have more like lessons learned, and we know our challenges. So we want to share with you. Maybe it will be useful in your own implementations, or maybe for some of these challenges which we didn't solve yet, you will be able to advise us somehow. And where are we now? So we will see the context of this deep platform, our internal development platform and engineering excellence. Also, because we built a big community around all of these frameworks and tools, we are going to share like how we did it. And later on, we have demonstration that Patryk will run, and some plans for the future. Happy to hear also your feedback and questions in Q&A later on. So I need to show this slide because of 2 reasons. I believe maybe there are more. First reason is that maybe some of you are looking for a job, so we have job postings, and it's just good to know a few things about the company. So that's first reason. The second one is this scale that I need to say, because if you hear about bootstrapping and templates for infrastructure for applications, it might not be applicable in every company, in every use case. If you have like small startup of 10 engineers and you don't develop new applications, new products on daily basis, you don't need it probably that much. In our scale, where we have like over 300 IT people only in Kraków and many locations all around the world, in total almost 80,000 employees, that's more challenging, right? Then also a couple of interesting facts is that we have people from more than 20 nationalities. In IT Hub Kraków, 33% of positions are held by women. And also we have this equal salary certification, which is quite connected to that. When it comes to IT, we have different departments inside of it. So it's related to AI, big data, DevOps, infrastructure and cloud, and more. So these things you can actually discover by going to our jobs portal. So this development at the big scale, I'm pretty sure this slide was also in this 60-second edition of Meetups, is just presenting how it works without any centralized cloud providers, teams, and standards. It basically is one big mess with a lot of dependencies between the teams, a lot of duplicated work and efforts, and sometimes it leads to to waste of time, waste of money, and more. So when we have such a big scale, we need to somehow lead people to write solutions, ship to them good practices, standards, and also we discovered that it will be just easier to build some templated solutions and ship them in that form so that people can adjust them and run it very quickly. In general, these problems can be summarized in that form. So we will have obviously these small and medium scale problems as well, because this is connected very much to technology. So how to address complex technology issues in the cloud, in programming and more. But also when it comes to infrastructure provisioning, right? So infrastructure provisioning will, when you don't have any team or any person deciding on single cloud provider, that will lead to, lack of cost management, different licensing issues, and in general, it might not be effective. And when it comes to the technical side of it, choosing right infrastructure as a code tool and provider will be also crucial to avoid differences and configuration drift between the teams and applications. Also, this toolset independence. So basically, if we take an example of even project management toolset like Jira, right? At some point of time, I guess in 2018, we discovered that there are around 20 instances of the same tool all around the world. And we took significant effort to migrate it into one instance because it was just ineffective when it comes to the cost. And we had many administrators doing things differently. So it's just also impacts everything from the financial perspective to also security aspects and probably more. And it's not integrated, so you can have like project in different Jiras and you cannot even relate to it, right? And processes and change management, as I call it, it's also important because without this alignment and without this, processes that runs your dependencies that helps you to solve that issues, it will be just difficult to manage. So the solution that we came up was to obviously centralize it. And many people tried to build solutions, like central solutions. We set up some central tool set, but it wasn't always enough, right? I mean, one team was dealing with, for example, this project management tool set, the second one with DevOps related. There was also a team dealing with cloud providers and so on. But it still wasn't enough. So it's a good direction, but not yet something what we could do. And throughout our history, to achieve some DevOps culture in the company and quite robust set of tools, We went from setting up the DevOps team in 2018, and it was also at the moment that we started thinking about tools like those for CI/CD configuration management, like Ansible and so on. And we, I believe, achieved it. We had quite nice set of tools, but it wasn't also integrated. It wasn't like consistent when it comes to support and how to even get it, how to get access model, right? So in 2020, the decision was taken to build IDP, internal developer platform. In our case, it's called Deep, and Patryk will say a few words about it as well. And it basically consists the toolset all together with cloud provider, and ships to users as a consolidated solution, let's say. And then after we have all of these tools and all of these cloud-related things, we also need some kind of standards and good practices and knowledge base. So around 2022, engineering excellence team was formed to create also some kind of knowledge base and repository of good practices and standards. We integrated it with Deep. We built the templates engine that we are talking about today, and since then we are delivering new templates. We are shipping them to users and maintaining it. So in the future, we want to push it towards more automation and more, let's say, better templates in a self-service manner. So I believe that's something that we are going to do in upcoming months. And I can pass my voice now to Patryk to say about, to start with this moment that we have cloud provider, but what next?
Okay, I'll take that. Yeah, cloud provider. And what's next? So basically, Łukasz already kind of told you the problems that we had when it comes to having no centralized platform, having no standard, and at the same time deciding to migrate like resources, deciding to migrate software to the cloud. So let me just kind of sum it up for you, summarize this, what we've already said, and we'll move on from that point. So first three. And the third one, yeah. So first three topics connected well with like cloud management, day-to-day cloud management, more high-level look at the cloud, so how we deal with the resources, how we behave when it comes to the cloud. So cloud governance and configuration management, which is also connected with like security of the infrastructure, because proper configuration when it comes to cloud, when it comes to like baseline in the cloud, ensures also some extent of security when it comes to the cloud infrastructure. Security of the application, this is more connected actually with what we do with the templates. I will introduce you to the templates topic in a moment. What's more? Cloud pricing, obviously not important, absolutely not important for DevOps engineers, but super important for my boss here. Yeah. No, but seriously, cloud pricing also and cost management, important terms when it comes to the like whole corporate, right, to big organization, right? Migration of the solutions, meaning migrating to the cloud in some organized manner, not doing it like completely chaotically, but thinking of some standards to follow. CI/CD, well, different teams spread across the world in different places. They might be using different toolset for CI/CD automation, different let's say workflows for that. Last but not least, IT members onboarding and application onboarding. Well, time, I guess, and when it comes to the time, it may take some time to onboard people, but also kind of expensive, these two things. And obviously, many more, whatever basically you can think of. With such larger organization, the problems basically arise. So yeah, so these are the problems, but actually what is the solution for that? So in our case, the solution was deep. So, at some point in time, someone wise decision, let's say, was taken to migrate to the cloud in organized way. Not to do it super chaotically, to just come up with some process that will be cost efficient, that will be time efficient, and of course that will allow for some, future, let's say, development, some further development when it comes to the cloud and cloud resources. And and this is where PMI built internal development platform called Deep. So. Yes. All right. So Deep basically consists of like set of tools, right? It provides cloud providers, but also automation and customer support and customer portal. Thanks to it, users can basically request a virtual space for their product, for their projects, and they will receive some predefined consistent toolset already integrated with like, for example, single sign-on. They will receive some AWS accounts, some configuration and security baseline, but also like project management and, for example, I don't know, CI/CD automation and what's more, Bitbucket repositories. Yes, quality tools, of course. In addition to that, Deep is also equipped with, as I mentioned, customer portal with a user-friendly customer support form that basically we can use it to ask questions, to request stuff, or just submit a request because we found some bug somewhere. So okay, it was Deep. We had problems. Now we don't really have them. The solution to these problems that I mentioned before on the first slide was Deep. So what else? Like what's next? So Deep was already a great way to kind of it provided some baseline, it provided toolset, but it did not fully consider all software and infrastructure standards. So at the same time, it kind of opened a room for like discussion about setting up some global standards, global guidelines. So this is where E&E comes, engineering, and we basically put on top of Deep, of course, we put engineering excellence bootstrapping knowledge base and templates concept. And about the second one. So you might already saw this slide somewhere in the past because, Łukasz already presented it at some point. So just a reminder, just as a kind of reminder for you, what is like a templates composition? What does a typical E&E template consists of? So basically, for us, the template is like a simply reusable, let's say, code, reusable infrastructure, some software added to that, obviously documentation, and on top of that, we've got engineering excellence support. So it is done in this way to basically allow for sharing the templates across the whole organization, across the IT teams in PMI. So it is highly customizable. It is also modular, and examples to the modularity can be these two templates that you can see on the screen. So template one was the first template that we've come up with, and you will actually see pretty soon a demo of that template, of deployment that template into some test environment. Template one consists of CloudFront, Route 53, S3 bucket. We have also some static side code added to that, and obviously CI/CD automation, CI/CD pipeline. Template 2, on the other hand, is also a nice example because we've got ECS ECS Fargate service powered by some Dockerized Python application. We have also here some auto-scaling policies. We have load balancers. And what's more, we have here monitoring done via the CloudWatch in AWS. Obviously, also backed up with some CI/CD pipeline and our guidelines. So such composition of the templates, we believe that it makes them complete. So it is not only about like standalone sample application, right? Standalone code. No, we provide basically the whole package. So it is not only about sample application code. It's not only about Terraform infrastructure. It's this and Terraform infrastructure plus sample application code. We have CI/CD pipelines. What's more is documentation and our support, obviously, and some maintenance and updates. So we believe that this kind of standardization also introduces another, let's say, positive effect. So because of that, the templates are not only like technically correct, right? So it's not only that they are working properly, right? It's also the fact that they are secure. They are compliant against some ITPF policies and compliant against some other corporate policies. And for such organizations as ours, it's definitely important. All right, moving on. So to convince the unconvinced still, because I see your faces and you're like, oh, okay, templates, I don't really get that. Let me just explain it in the simplest terms I possibly can. So you can see on this slide the usual way of developing some solutions, right? On the left side and on the right side, how does this development works with the template? So I'll start obviously with the left side. So the typical usual way of development. So it starts with some planning. I mean, you have to have some idea, some goal, what to do, what do you want your application to do, all of that stuff. Then you have to plan your work, obviously, kind of in advance. Then you have the third step, which is kind of important, which is the development of the application. And here, obviously, you can take, for example, Terraform modules that are already in some public TF registries. You can obviously do that. Of course, you don't really have to start from scratch, but still you will have to combine the modules somehow to make it all make sense. Then you have to test it, obviously, after test it and probably write some documentation. At the end, last thing is maintenance and updates. So you have to ensure that this is like, when it comes to security, this is compliant. You have to update your, I guess, your software. Yep. So imagine if I tell you that these 5 steps, someone can do it for you. And this is exactly what we did with templates. So basically, we took these 5 steps, this like development from the very beginning through the testing and updating and documentation, and we are providing the templates, this like whole complete solutions to our customers, which are obviously PMI IT colleagues, so that they are basically able to download our template, take our template, read the documentation. They can but don't really have to, not always, change some variables and bam, deploy it into their environment. And you will see that actually when it comes to demo, deploy it into their environments, and well, that's basically it. It's not always that pretty, yeah. So I'm saying it's super easy, quick, and efficient, but it's not always that easy. We also had some problems, some challenges, but more about that comes from Łukasz.
Thank you. It's not that I'm always coming with bad news or something, but yes, indeed. I mean, it's not always that perfect. We have some issues and challenges all the time, definitely. Initial problems were definitely to get people into this framework and like make them use it, like how to encourage people that want to develop their own modules, they want to develop their own CI/CD pipelines. And I mean, we cannot force them fully, right? But if we show the benefits, if we show the savings, they're encouraged not only by us then, and we also can show the fact that we are lowering the bar that is for entry level to get into the tools that we are using. So if you can develop simple application, you see the effect after 15 minutes instead of developing whole day and calling people and being mad. That encourages people to use it. What's interesting, we in the beginning, because our company is full of IT enthusiasts and really good people in technical skills, we got even more contributors than ideas in the very beginning. So I put it as a challenge to get contributors, but it's not related to get like people interested in contributing, but people like willing to contribute. And a few words about that in a moment. Also to define proper templates and ideas, right? So Patryk told you that we are doing it almost perfectly, following all of the best practices, of course. But it's also the matter to not only do things correctly, but do right things and choose right templates, because we can spend 10 weeks building some great EKS template, and well, it will occur that our company is using something else, right? I mean, so we need to stick to what people are saying. It's not only like we need to use our hard skills, but even more often our soft skills in order to or create surveys, talk to people, and get really good outcomes out of it. Then to maintain the template. So very often I got a question also in conferences, like let's say that you updated, you have new version of the template. How do you push it to the people? So I mean, we push it definitely to all of our customers, saying that there is a new template available, but it's the same like in AWS. The same is followed by our deep platform, and the same is followed by ENE. We have some kind of shared responsibility model, because the fact that you use template might make your life easier, but it will not release you from all of the responsibility, right? So we are saying, okay, we built it in secure manner, we're following good practices, but bugs might occur always, right? So you need still to take care about updating it. If you are faster than us and you fix the module yourself, you are asked to contribute and close the loop of this contribution and feedback. And last but not least is about managing the workload. So I show you you could see the numbers about our company, and you may imagine like this migration to the cloud that Patryk said, it was like 600 applications, right, in total. So we have obviously more products, I guess around 800. And you may imagine like the demand is big. If we even have like dozens of engineers in our team, it wouldn't be still possible to cover everything. So we need to address it by contributing actively to what we have and asking for contribution, and whatever people are building and is working well, we're asking also to share it with us. So to summarize, like how it works with this community, right? So we have Deep, this platform that serves all of the underlying infrastructure applications. We have ENE that on top of this Deep platform is building templates and these reusable solutions. And then key player here is the community, who are people who are involved actively into giving feedback to Deep, into giving input to ENE, and other way around, right? So it's basically like fundamental thing for us. But community, how to actually make it happen, right? So I'm saying like, okay, people contribute, everything is green, and we are super happy. But you may realize that in big corporate, it's like people don't really want to contribute to somebody else's job or whatever, right? I mean, there might be many reasons that are blocking or preventing them to do that. So few tips how to address it. First of all, it will be to provide guidelines saying like how to contribute, because usually, even before ENE, before DEEP, we had like repositories that people could contribute to, but nobody knew how. So that's very trivial, but important thing. And also common sense, respect to priorities. So we are contributing to some templating engine. You are not doing your first priority job. You are not meeting your yearly goals or whatever, right? I mean, it can be taken into consideration probably, but we need to be reasonable and don't push people like, okay, you promised to deliver me this template, although you are working for completely different thing. It's not like that. It's more to support these people in contribution. And then the knowledge base and repositories they contribute to this should be somehow recognized already. It's easier, much easier then. So building this brand is very important, and there should be some authority to contribute. So forget about list of approvals to get my documents there. It's not like this. We treat it more like, okay, you contribute, you take some responsibility of, putting your name there and being a contact point for that thing. So there is authority, but it's, I believe, encourages reasonable people. And credits and rewards. So I mentioned about putting your name there, and it was first thing that unlocked many people who are adopting, okay, what I have from contributing. Even if you put name as an author of the documentation of the repository, people can show it, can go to their boss and say, oh, look, I contributed to entire community. It's some kind of open source within a closed company, right? So that makes it way easier. And it was also like discovered quite early, and I'm happy about it. Right now, we are going to move to the demonstration. Yes, I'm right. Oof. And giving my voice back to Patryk.
Thanks. So you guessed it right. We will be now seeing a demo of template 1, downloading from the DEEP portal. We'll be reading, we'll be just scrolling through the documentation. I will show you Bitbucket repositories, all of that stuff. And last but not least, we will deploy the template into the some test environment. I cannot say into the production, right? But we'll deploy it, no worries. Okay, so let's start. We'll be showing the first template. So S3 plus CloudFront. This is the portal, and you can see Engineering Excellence product code there. So we will be clicking on that. You can see overview of the product and template step. Also, we'll be exploring service tenants with some baseline services provided, like AWS accounts, all of that stuff. And now we're clicking on the templates. And we should see a list of templates, 8 templates on this presentation. I think right now we've got about 11. So we are still growing. We'll be downloading the first template in like 403 version, the latest one. And as you can see, a short description and direct links to basically Bitbucket, a repository with code, and conference page with documentation of that template. We can also download the template directly from this portal. Right. So we are now browsing through the documentation. The first template documentation, let's say. Prerequisites table, so some general stuff, what we tested with this template. Architectural diagram, I think quite important for us, because we want to basically give some graphical perspective of what's going on with this template for the users. Quite large and long tables connected with variables. As I mentioned, the templates are highly configurable, so basically you can change a lot. Infrastructure, some short description of the infrastructure, source code. So again, HTML and CSS files in this case. Functions, that means further customization options. CI/CD, monitoring, because CloudWatch is also implemented into that. Logging, And then last but not least, quite important, the deployment guidelines. So as you can see, they're quite simple. You just need basically to download the template and copy the files, commit, push, and apply the Terraform plan. Quite simple. And we'll be doing that shortly. We are now in Bitbucket. As you can see, template 1 repository README. We want, compared to the documentation, you can see it's quite short. But this is on purpose. We want to keep README as short as possible, just in general to document what's going on in the templates. And when you want to go into the details, you are welcome to browse our documentation. Right. So let's deploy the code. We are deploying one of the examples that we provide for the customers. So Łukasz will show you actually in a second that it is it is quite simple. Yes, so we can see basic Terraform files, locals, outputs, providers, variables, all of that stuff, and main S3 CF file with the module call. Here you can see the first output that was there. It's quite important because we'll be using it to access the site that will be deployed with this template directly, after applying the plan. Module call, as you can see, is right here. We will be uncommenting one line, actually here, 115. Because we are not using CI/CD, this is rather a simple example, and we don't need the automation here actually. So we'll uncomment it, and we will be shortly moving on. Yes, probably. Yeah, again, module call. Variables section, you can obviously, there are some defaults, you can change these defaults, you can provide your own. Yeah, so now let's commit and push the modified files. You will be able to see soon that we are using Terraform in enterprise version, and that's why we have this nice user interface here in place. So we started already the plan. Plan is running. We should see pretty soon the resources that are planned to be deployed using the Terraform. 41 resources. So quite simple, just a few files. You basically don't really have to change anything there, right? Because of some default values already in place. And 41 resources will be deployed, so quite a lot. Right, so we are just browsing through the planned resources, and the apply should be running pretty soon. Yeah, okay. So apply is running. We'll just have to wait another few moments, and we should see the infrastructure in place. So again, you will see soon that we'll be using output, let's say, section of the Terraform apply. You will see we are using uplink output, and we will be simply copying the text there, which is a link to the static site that will be deployed using this template. We will be pasting it to the browser, and voila. It's that simple. Uplink output, the first one. We are copying it to the browser, and well, hello world. This is our sample, let's say, static site that we provide for the customers. And if they are able to access via this link, then it means it worked. The template was properly deployed. We already saw their engineering excellence service desk, so we kind of established that in order for our customers to be able to contact with us, right? That's it. We've come to an end when it comes to demo. So right now we are jumping kind of into the future with Łukasz. Go ahead.
Okay. Thank you, Patryk. And I mean, it's interesting that you were a bit surprised it was successful, but it was video, if you didn't notice. So although you see templates can make your life easier, but you could say, okay, there are some Terraform modules that we could reuse, right? And they're also having examples. But here there is also, few different things are covered, like these good practices and these policies that we have internally in the company needs to be covered. So we have some kind of repository that makes it easier for people to deploy such cases. And this was a pretty simple one, this CloudFront, right? Nothing, no rocket science, I believe. But we have obviously those for more interesting cases, but it would take a bit longer to also show it. However, even though it's like making life easier, it's still not perfect, and we have a lot of job to do, especially in this area of building some kind of marketplace, because there is still some kind of impression that you need to know a lot in infrastructure programming or Terraform infrastructure as a code, whatever, to start using templates. We want to avoid it, and for these simple use cases where people don't need more than some CDN or CMS, we can build marketplace where they can even use graphic interface to fulfill these variables or choose them from some dropdowns and push it within minutes to the cloud. So that's currently our plan. The goals which we want to achieve is to provide this full automation of that, to have portfolio overview also, because right now we have templates, you use template, you have product, but it's somehow disconnected. We don't have full control of what templates are used, how many people are using it. I mean, we have statistics and data, we know it, but it's not displayed even for these people. It's not clear if they are using it, if they can change the configuration or somehow impact it. Yeah. And obviously it's to simplify, so like to make it just few clicks and few clicks and make it available in the cloud. And that's it from us. I believe now that's the time for Q&A. So there was a question already. Okay, I will answer in English, okay, just for matter of, I don't know, like maybe there are English speakers. So if the templates are created just for a particular use case, particular team, it depends. Like we obviously measure the demand. So if there is somebody coming, we have this service desk, we have also more direct ways to contact us. People are coming with ideas, and if they say, okay, we are going to have like 10 teams using these templates because of 10 different markets, then there's enough demand to to be very heavily involved, to involve our team and work on these templates more. So it's actually up to the community and also up to us what we want to put in place. But in general, contribution is like generally available. We don't limit it anyhow. And also the measuring the demand, some of these templates, like the first one and second one, for example, that was our invention, and we used some survey to even get most common setups, and also some data which were already available in AWS. So we queried what do we have and provided this kind of solutions. I hope that answers. Okay.
Do we have any? Oh, okay. Here.
Hello, guys. The question is quite maybe not easy, but easy to start and create some templates because you have some idea how people may use it. But how you are like extending the template and how you are keeping it up to date, because from the security perspective, it's quite important to have it up to date, secure, and maintained.
Yes. So how do we do that? As mentioned, I want to emphasize one thing, that it's still responsibility of users of the templates to keep it up to date. Like the same, they would use modules, they would use Docker images, right? Which might have vulnerabilities. So they need to update it. But how do we do that? We are constantly scanning the images, for example. We are scanning the code. We also implemented our internally written tool, which is for Terraform validation, and it is also performing these scans, and every new implementation, every new version is scanned, and we are pushing respective message to the people. We are using deep communication channels, so all of the deep users and so all potentially interested customers of ENE are receiving this notification that there is some important change. And if it's a security matter, obviously we are like making it more visible, if I may say it like this. There was a question in front, I guess.
Yeah, okay. Also, I have one question in the same.
But you will not get the prize, sorry.
Yeah, I know this. Although my question is, because you said that everyone should take their ownership over the template. So basically, if I'm an insider threat and I will submit some malicious template, do you have like any, I don't know, monitoring or any? You will get it, or rather, if somebody will use it, then you've got malicious template and spreading some malicious configuration.
Very nice catch of what I said, because I tried to to be fair and to say like we want no approvals and so on. And now I need to say it's not like that. No, it's we are part of code review, right? So the contribution, you want to implement something, again, you will bring the infrastructure module and it will go through our validator. So it will run many, it is running actually many tools all together. Like TF-Lint, like some security scans, and also Checkovi, I guess, and also set of our internal rules that we have in terms of like clean code and formatting and so on. So that's first thing, that a lot of these controls are automated. When it comes to Docker images, we also scan it, right? When it comes to code, we also scan it, and so on and so on. So basically, we limit the chance of some kind of malicious implementations coming from the users as much as possible by automation. But we also have some last word when it comes to publication. So we need to take a look at this, and usually it's like we still find time to test it on our side too. And when testing, that even in AWS the security score will drop if there's something very bad. So yeah, we try to do it these ways, and obviously nothing's perfect, right? So maybe somebody will find a way, but I don't encourage it.
Okay, thanks from me. And there was a question, yeah?
Yes. Okay, 2 questions.
Maybe more general questions. All this infrastructure is based on Terraform. What about the people, for example, that prefer CDK Cloud Development Kit? Is it possible or not?
Okay, also tricky question, how to be nice here. No, for Terraform is our preferred and chosen infrastructure as a code tool. I tell you why we have like usually preference to choose one tool, single tool, is because, I mean, okay, maybe not this kind of tools, but it will create some kind of drift between like teams. And also for enterprise versions of that solutions, we need to pay for them. So as you may imagine, it's not possible to maintain like 4 contracts for the same, because you will not justify it. And if it's possible, there are some implementations that using native tool to AWS, which is CloudFormation. For CDKs, I know that Terraform even is cooking something for this Python, right? And if I remember correctly, so we are assessing such tools also as part of ENE. But to be quite honest, we are not implementing too many, because Terraform for now was fair enough to address all of the cases.
Okay, who next? Here you go.
So you have introduced this initiative, DEEP. So you introduce it, then you are now expanding it, maintaining it, and so on. So you probably, and you are a big organization, so probably also multiple voices. So I'm guessing that you had, or maybe you still have, some voices, opponent voices, critics, maybe some accusations, and so on. So that, like, from the other side of the world, that somehow you're doing it wrong. And the question is, do you have such voices? What are those voices? What are the most loud voices? Me specifically, I'm interested in, are there any accusations or critics that it is some sort of over-engineering? But overall, what are the critics saying within the company?
Yeah, okay, very good question, to be quite honest. First of all, I need to give credits to some people, so to colleagues maintaining deep, because as you, if maybe it was difficult to notice, I mean, my team is mostly responsible for the template standards and this part, right? But the platform itself, we have a bunch of people doing that job. We even have some kind of the enablement team for the cloud who are gathering initial feedback, and there are like levels of support, like nothing strange for any IT service, right? So there is a feedback, of course, like coming to the services, to its configuration. And I would say that from my experience, because we are also reporting these issues, we are also saying, okay, guys, maybe you could do it differently and reconfigure Terraform to do this and that. It's that we first of all need to register it, so it's very official, but it's like everybody tries to keep some flexibility to retain it and to assess what's possible. Last example can be like we were trying to evaluate no-code modules from Terraform, saying that okay, that maybe because we are using this enterprise feature, it will be just easier to skip building our interfaces and expanding portal and switch to that. But yeah, somehow we get into discussion. We created some small POC and noted outcomes, and based on that, deep taken decision. I mean that's something that you can tell to them. You can tell to us also about templates. That's one of them is over-engineered, or maybe that it's simply doesn't meet your expectation, and we try to act, right. I mean, depends on the priority, depends on the impact that it makes, but we do what we can.
Hey, thanks for the talk. The demo was nice, and the question I have is, I haven't really seen the backend file for the Terraform. Is it generated in some way with the running of the pipeline? And also, I haven't seen the pipeline itself, the configuration files.
Yes, so starting from last part of your question, pipeline wasn't here, it was simplified version of the module. It's possible to use it, right, I guess, like officially, but we have also like a pipeline provided in case you want to synchronize it. Of course, what we didn't say is like, after all of this, you still need to take care about business logic, write it, and I mean, publish your site, not the template site, right? So CI/CD especially might be useful, but if it's like static site, you don't plan to update often, we keep this possibility to do it like this. And you mean this Terraform main files, right? So because the module for that implementation, the backend is okay, so we are using Terraform Enterprise. We have registry of modules, and it is configured to just pull from this registry so that people cannot modify directly the underlying files, but they're only invoking the module in their files, in their repository. When it comes to backend, I guess we are using like remote backend for Terraform Enterprise configuration.
Yeah, and where this backend is specified, so already in a template?
Okay, so not really. So that's something that Deep provides. Every repository for a product contains some kind of baseline files that configures this backend, right? So they for example get like 3 AWS accounts for one per environment, and let's say every branch contains like this configuration so that they go to particular remote workspace. It's called like that, I guess. It's
All right. And what comes to the Deep website, is it just written from the scratch or based on some open source tool?
Okay, so you mean Deep portal, right? Yeah. This website. Okay, so Deep is written from scratch. I was also happy to be like a project leader of Deep portal a few years ago. Yeah, it's just a page written in mostly React on the front end and Python and more on backend. So
right, thanks.
Cool.
We'll be taking the last questions. Do we have any others?
Do we have online?
Maria, do we have online?
Yes. Oh.
So you guys are getting pretty drilled here.
That's okay. I mean, as long as I manage to answer it.
Have you had a chance to check out Backstage or are you mainly interested in Terraform, in templating?
Great question. Thank you very much, whoever was online and asked that. I mentioned about like early stages as well of Deep. At the moment, Backstage wasn't something really like a market standard. Right now, the world is different, and obviously Spotify spent a lot of effort to build like a good solution. And maybe I can share, like we are evaluating a lot of tools like that, also to use it as our backend. But because we have already some brand, because we have some portal, for now we are using it for the main customer interface. But we also evaluate different engines for different use cases. What's good about Backstage is like a lot of custom and a lot of actions that are already present there, and possibility to extend it endlessly, I would say. So that's something we are also taking into consideration. Was it the last one?
That was the last one, I think. Yeah.
Cool.
So thank you, guys. A big applause, please.
Thank you. We have something also.
Also, let's remember about our quiz, when you, as always, can win some coupons for AWS. And as always, we also remind that it's not for Amazon. You cannot order, I don't know, like new devices or stuff like that. You can buy some EC2 machines or storage or any service of AWS you want. So it will be here. And right now, we'll be having a short break to change speakers, devices, and stuff. The next speak, as I was saying, will be Dmitry with networking in AWS. So let's give us, I think, about five minutes. And thanks again. In a minute, we are starting. Okay, so everything works again. Let's have a seat. Let's start the next presentation. So, as I was saying before the break, Dmitry will be going through networking in AWS. We'll also hear about some new services. And let's give a big round of applause for Dmitry. Great, and the scene is yours.
Thank you. Hey everyone, can you hear me all right? Awesome. All right, let's get started. So networking is one of important pillars of application infrastructure, which can have a huge impact on your application performance. And in this session, I'm going to tell you about how to design resilient applications, multi-availability zone, multi-regional applications. There will be huge focus on load balancing and DNS. So we'll take a look at load balancers and some different application networking services, as well as also some fundamentals and newer features and services in this area. I do hope that by the end of the session, you are much more confident with building applications and architecting applications on AWS. My name is Dmitry. I am Senior Cloud Architect at AWS Professional Services, and I help customers design scalable architectures on AWS. My main expertise is in networking. Right, so let's start with like fundamentals and how application developers perceive networking. So the expectations usually from application developers that you have, let's say, a client and a server, and there is like no latency whatsoever, no packet loss. Maybe it's like direct cable of like half-meter lengths, but even that can fail. So that expectation is just totally unrealistic. And sometimes you just overlook that, that there could be so much happening on this networking layer that can negatively impact your application, and you don't even know about that. So in reality, it looks more often like this or even worse. So there is unknown paths between your client and the server. It can traverse hundreds of routers through internet, and
so on and so forth. The server itself can have so many dependencies, dependencies on storage or some other servers. Maybe to that dependency, it talks 15 times back and forth before it sends a response back to you, and you don't even realize it. Maybe it's in the same data center, so it's like 1 millisecond delay, but then you spread these components apart, and let's say the latency is now 15 milliseconds between components, and you have 10 round trip times. And now your application performance is degraded, like you wait for a second to get the response. So all of these things can impact your application. Now, as the basis of networking is this TCP/IP model used. We are using IP networks all the time, every day. This is the most common standard. So let's say if you have HTTP client and HTTP server, we want to exchange our HTTP gets or post or whatever we want. In order to actually send this data, we need to add some additional metadata or headers so that this packet can traverse the network from source to destination. So we have transport layer where we have TCP or UDP, so we add some port information. On internet layer, we add source and destination IP address, and then on network access layer, we add additional headers, and we actually convert information to bits and send it through wires or wirelessly. All right, so when we look at just connecting to hosts, and let's say we go through some network infrastructure in the middle, in this case, just 2 routers. On the right-hand side, we have our original data that we want to send, so header and the data, and then we add these headers on top. So TCP header, IP header, Ethernet header, whatever. And then on the way back, we will reverse some of this information, like IP addresses and ports. Pretty straightforward stuff. Though the thing is, we never really want to use IP addresses. We prefer domain names. So because no one wants to remember like 10.1.1 whatever, or 1.2.3.4 or whatever the real IP address is, we use this human readable notation for our hosts on the internet using DNS. So we will ask our DNS server of, okay, if I want to reach my server domain or AWS Amazon.com, what's its actual IP address, and that DNS server will reply. Now, I'm oversimplifying it because behind this DNS server, there is just another layer of complexity that is happening to actually do this DNS resolution. But that's just not the point of today's talk, though. This is another interesting layer of complexity. Again, not all application developers think about that. So again, we want to send our HTTP data. And in order to do that, first we have to establish TCP session, which is TCP three-way handshake, which takes 1 round trip time. Then if we are using TLS, which pretty much most of the websites right now are using TLS, so then we add 2 additional round trips. We exchange 4 more messages before we can even send the data that we want. And then we have some characteristics of TCP, which at some point, if there is some kind of packet loss on the network, the performance of TCP can drop significantly because of that. So there is this like hidden complexities and hidden things that you have to think about when you're working with your application and thinking about optimizations and thinking about what are the dependencies, how far things are from each other, how many times you have to go back and forth, and so on. All right, so this was the basics of, well, of networking. I will not really go further on like general networking. Now we'll focus on a little bit more about building resilient applications on AWS. All right, so first, before we even do that, we need to understand what we are trying to achieve. what are your requirements, what are your business goals and recovery objectives. So there are two main characteristics: RPO, which is recovery point objective, which is how much data are you willing to lose in case of some kind of disruption, and it's measured in minutes or seconds. And then recovery time objective. So if an unexpected event occurs, how much time it takes for your system to recover. Then another interesting part is how do you replicate data in your distributed environment. And then lastly, you would want to identify the correct disaster recovery solution for you, because there are a number of options to choose with their own RPO and RTO characteristics. Let's look at that just very briefly. So in general, we have two categories: active, and active passive. And in active passive, there are variations. So the one with the highest RPO, RTO would be backup and restore. So let's say you take a snapshot, and then if something happens with your server, then you restore from snapshot. So obviously you will be losing a lot of data since you make snapshots every so often periodically, and then it also takes time to recover. So this doesn't cost that much compared to other options, but you're sacrificing those RPO and RTO characteristics. Then we have Pilot Lite, where we actually synchronize the data, but you don't spin up any services yet. So maybe with auto-scaling groups or something like this, in case of, let's say, some instance crashes, then you spin up a new one, maybe in another availability zone or something similar. So the data is there, but the service has not been preemptively scaled yet. So our RPO characteristics are much lower now, but cost increases. Then another variation is you have warm standby. So you actually have data and you have compute resources in your secondary location or whatever that might be already running. And then in case of unexpected event, you can switch over. And then active means obviously both of them are active at the same time, which is costs even more. All right, so I also mentioned data replication. Raise your hand if you know about CAP theorem. Awesome, that's a lot of hands. All right, so very briefly, CAP. So it's consistency, availability, and partition tolerance. It's a triangle where you can only pick 2 out of 3. And the idea here is that in distributed systems, you have to sacrifice something for something else. So you cannot sacrifice partition tolerance because it says about that, well, the system still is operational if there is some kind of network disruption between nodes. So in distributed systems, like you cannot have like an active system that doesn't have this property. So what you're really trading is consistency over availability. And let's say if you select consistency, and the idea behind consistency is that the clients that access the system will have consistent view of your data. So regardless of like where they go, the data will be the same. So if you choose consistency over availability, then you need to make sure that the data is there regardless of whatever the event might be. So you might use techniques like synchronous replication, or like with some, let's say, quorum-based systems where maybe out of 3 nodes, you have to write to 2 first, get the confirmation, and that's where your transaction is considered complete. But if you do that, you sacrifice availability, because now you have to spend time on actually doing the synchronous replication between nodes so that multiple nodes can do that. And then on another hand, you can select availability where your system is available during the event, but it might not have the latest data. And this is often a characteristic of asynchronous replication. So instead of waiting for the data to propagate to all parts of the system. It's, let's say, only on one part, and then something happens. Your system is still available, but it doesn't really have the latest data. So then you can, once it returns back, you have to think about how do I reconcile this data. So there are all these kind of problems. But the key point here is you have to pick two out of this. You can have all three at the same time. And in general speaking, if you choose synchronous replication, you gravitate towards a strongly consistent system. And then if you choose a synchronous replication, you would prefer availability. And then another interesting part about here availability is if you do synchronous replication and the latency between nodes is not very high, you don't sacrifice a lot of availability. But if the latency is high, let's say between regions, then the availability suffers much more. All right, let's start building our service as resilient as we can. Let's see how far we can get here. So we have clients, and we have a data center, and there is a single server. Well, awesome start. We will just deploy our application there, and then we can access it. The problem here is that, of course, it's single point of failure. We have just a single server. So anything happens to that server or application, there is not much we can do really here. Our system is down. Right, so to fix this, we will just have multiple copies of this, and maybe use load balancer in front of this. So now we no longer have this single server failure problem, but you still probably have single deployment or single configuration change. So maybe when you do this, let's say you have a single Docker container that you deploy to different places at the same time and single pipeline. So like something wrong there, like all of your system is down still, right? So that might also be a little bit problematic. So what we can do is treat those separate services like their own replicas. And the idea here is that you no longer touch them at the same time. You just do action on one, and then you observe for some time, and then you can repeat this action on another part. So this way, you are mitigating those problems with, let's say, single deployment, single config change. But then we are still in single data center, so we have all this kind of other problems. So network issues, infrastructure issues. There could be power outage. There could be flood. There could be earthquake. That happens, again, everything in single data center, your application is down. Well, what we can do here is, of course, use multiple data centers. And in case of AWS, this would be availability zones. All right, so we can fix those issues. And the important part here is that you want those data centers not to be very close to each other, because things like flood or earthquake, for example, can bring all of your data centers down if they are in the same location. But you also probably don't want them to be very far, because in that case, all of this kind of synchronous replication stuff to do is much harder. So again, there is a trade-off here. There are still problems remain. So we just talk about compute. There is storage. So oops. How do we do resilient storage? There could be other dependencies of our system, which we don't know their characteristics. There could be denial of service attack as well. So there are a lot of unknowns here. Let's try to mitigate some of it. But before we do, let me briefly remind how AWS builds their infrastructure. So we have a number of AWS regions. Each region consists of 2 transit centers and at least 3 availability zones. All of those are connected via full mesh, so AZs and transit centers. And you use transit centers to access other regions or internet exchange. And single availability zone is at least one data center. Now, one key characteristic, as I said, they are not very far from each other, different AZs, but they're also not very close to each other. So they're around up to 100 kilometers away. And what we say is we provide single-digit millisecond latency between AZs. Though in practice, you will see for most of the AZs, if you there is, by the way, a service in your console called infrastructure performance, where you can see latency between different availability zones and regions, and also historical data about this. So the very common numbers that you will see is around sub 1 millisecond. So that's pretty nice. So we have more than 30 regions now and more than 100 availability zones as of today. And now let's take a look at the standard architectures. And again, we will try to improve on those as we go forward. So in this case, we have our clients and they access load balancer. In this case, it's network load balancer, but doesn't really matter. And there is an instance of this load balancer in every availability zone, as well as we have targets in those zones as well. And then we have some kind of resilient storage. So between different AZs, we have multi-AZ or AZ resilient storage in the region. Something people don't often realize, there is huge integration between load balancing and DNS. So the load balancer often does health checks for the targets, but the Route 53 DNS service also health checks the load balancer itself, because not only your targets can go down, your load balancer can go down. So it's important to monitor both. And let's say the instances in particular AZ go down, DNS can remove the entry for a specific load balancer in that AZ. Even though the load balancer might be healthy, the targets behind it might be unhealthy. So we remove that entry, and that kind of integration is there built in. Right. Another common architecture is serverless, standard serverless architecture, where you have clients, they access something like API gateway, they then go to Lambda and then to Dynamo or S3, it doesn't really matter. One thing that you notice on this picture compared to previous picture is we don't really have availability zones here. And it's actually a pretty nice property, because if you use these services, those services are all regional. You don't have to think about what do we do if there is a problem in particular availability zone. This will be a responsibility of that service to make sure that it's resilient. If you have architecture like this, for part of it, you have to think about what do you do if there is a problem in particular availability zone. So if I were to build something new, I would probably try to gravitate towards this. But it's important to understand what kind of things you have to think about if you select, let's say, standard like VPC-based architectures. All right, so let's try to think about what we can do to improve this VPC architecture. Before going there, there are two notions that are important, which are hard failures and gray failures. So the hard failures are pretty easy to understand and digest. Let's say your application just down or AZ is down, and then it doesn't respond to a health check. So it's just being removed by the load balancer from its pool. It's like no big deal. Like we have been doing this for ages. The gray failures, though, are a completely different beast. This is where the health check is not failed, but your application performance is degraded. It can be a packet loss, it can be increased latency, it can be increased number of unhealthy hosts. So something is happening, but like you're not really sure what exactly, but you see degraded performance. And like, what do you do? Like your health check is green. What's your next step here? The idea here is to try to identify these gray failures. And if you can successfully do that, if we had a mechanism to move to another availability zone, that would be nice. So let's see how we can achieve that. But I will also give you some examples of gray failures. So it's extremely rare to see the whole availability zone down. But what you might see is, let's say, some ratio of instances lose power, or there is intermittent packet loss, or problems with DNS, or some instances fail to launch. Again, like some percentage, not really like this, like black and white of like everything is down. All right. So if you want to build easy resilient systems, we have to think about our each layer. So if you have multiple layers of, let's say, load balancing or application dependencies, we have to think about every one of those. You want to eliminate single easy dependencies anywhere you can. This is a very important one. So one approach to one approach you can take is, let's say, auto-scaling. The nice thing about this is it's costless, right? So you will take, let's say, an action if something bad happens, but it might take too long. So your RTO numbers are longer. What if you wanted less RTO? That's where you would want to pre-provision capacity. So you would want to make sure that in every one of your AZs, you have enough capacity. And we'll see later where we will try to remove one AZ from the equation. Can your remaining AZs still handle the load? Right. So that's exactly what I was talking about. That let's say you have 3 AZs and you lose a third of your capacity. You want to make sure that all other AZs can handle 50% more load. So you want to pre-scale that to make sure that you can accommodate that load. All right. So one interesting feature that I would like to explain and make you think about this just a little bit, which is cross-zone load balancing. Raise your hand if you heard this term before. Okay, we have a couple of hands. Nice. All right. So cross-zone load balancing in this case is on. So we have load balancer instances in every AZ, and we have targets in every AZ. With cross-zone load balancing, every single load balancer can reach every single target in any AZ. So there is a lot of potential cross-AZ communication. So that's kind of nice from this smoother load balancing. And also, if anything happens with load balancer itself, it doesn't really matter. All other load balancer nodes can target any other backend targets. The problem here is that it's hard to detect a single AZ failures. And there is just too much AZ interaction. So like if something happens with an AZ, it will be really hard to detect it here. If we turn this feature off, now we isolate our stack to a single AZ. So we provide this zonal isolation. So the upside is if something is wrong, you'll instantly start seeing this in your monitoring. The problem here is if, let's say, problem with one load balancer node, you just instantly lose half or a third of your capacity. So again, the trade-off. Right, so something else you can do is you can start monitoring your zonal stacks. So let's say we would build a dashboard where we would have some synthetic tests and we would target a DNS entry of a specific zone of a load balancer. You get it when you create a load balancer, you get a regional entry, and then for every AZ you have DNS entry. So, and then you will have a dashboards for every single AZ, as well as your overall like experience to the regional endpoint to simulate customer experience. So what might happen is if we'll start seeing on our graphs, and we can monitor here latency, we can monitor response code and things like this. It might happen that on one of these graphs, you will start seeing some kind of abnormal behavior, maybe increased error rates, maybe increased latency. And then also, like as a follow-up, your overall customer experience will degrade, but not as much as the, let's say, the metrics in that particular AZ. We'll see an example with some numbers a little bit later. So you kind of, like, if that happens, you're like, oh, something is happening with this AZ. It would be nice to like stop using it for some time. All right, so this is an example. So in this case, we have 3 AZs. We have this cross-zone load balancing off. We have success rate 4 nines everywhere. Then something happens in an AZ, maybe some power outage, and you start seeing lower success rate in that AZ. You start seeing this on the graphs. So, and then your overall experience metrics start to degrade as well, but just not as rapidly. So what you can do is, there is a feature called, so there is a service called Application Recovery Controller, or ARC, and there is a feature called Zonal Shift, which was released around 2 years ago. What you can say is, I would like to remove this AZ out of service. And I could also say for how long. So the consequence of this is we'll start sending the traffic only to AZ1 and 2. We need to make sure again that capacity is there already pre-provisioned, so that otherwise, if you don't have enough capacity, you will overload your existing AZs, and then you'll start seeing error codes everywhere. But if you do that, you take that AZ, problematic AZ out of service, now your overall success rate increases. And then you start an investigation of what's going on in that AZ. Was there some kind of new deployment in that AZ? Like some kind of code change, maybe AWS health dashboard reports, some kind of issues in that AZ. And then at some point you can recover this back. You can say, okay, the time has passed. We can now move back to our AZ and keep sending traffic to all 3 of them. All right, so this feature is pretty interesting. The idea here is that it's an API that is built to withstand AZ failures. Raise your hand if you ever experienced some kind of problem in AZ in your accounts or in your applications. What you might have noticed is maybe control plane for the affected services is also not functional at the moment. So let's say you cannot bring up new instances or maybe change DNS record or something like this while there is an AZ outage, right? So control plane is impacted as well. The way this service is built is to minimize those occurrences to make sure that this API can be used during problems with a particular AZ. And you fail from an AZ. And this feature is available for ALB and NLB if you have cross-zone load balancing off. And the common feedback from customer was, that's great, but why AWS will not do this for me automatically? Like, you guys know when there is a problem with AZ. You have all reporting and monitoring in place. And the team thought about it, and they introduced another feature called auto shift. And the idea here is you would mark your load balancers for an auto shift. You can opt into this feature. And if AWS detects a problem with a particular AZ, it will automatically take this AZ out of service from your load balancer. So we will take out the DNS entry. So we can no longer access that load balancer. Again and again and again, you have to make sure you have enough capacity. Otherwise, you will overload your existing services, and the result will be even worse. And what you need to do, and what we require you to do in order to use this feature, is actually you do practice run. So there is a system where you specify when you can run the practice run, and it will, during some time intervals, will take out AZ out of service in production, and you will monitor that to make sure that in case real event happens, this actually works for you and it doesn't make situation worse. All right, so some couple of key takeaways for this section. So easy resilient design is critical, and you would want to detect gray failures by using some kind of proxy metrics and really turn them into hard failures. So in this case, we noticed degradation of a particular AZ, and we just took the whole AZ out of service completely. This immediately improved customer experience. And then we now can go and investigate what has happened. It, of course, is balanced between the risk and customer experience and costs and how much time it takes to recover. All right. How are we doing on time? 15? Okay, awesome. All right, let's talk briefly about multi-regional architectures. So before even thinking about that, you would like to understand, are you well architected in a single region? Because maybe there are ways you can improve your resilience in single region first. Because multi-region might sound appealing, but it's not as simple as it sounds. Why are you doing this? Is it to lower RTO further? Maybe you have some data residency requirements where your data needs to live in a specific place. How are you going to do data replication? Now, inside of the region, we established that it's single-digit millisecond latency between AZs. Between regions, it varies. It can be tens, sometimes even hundreds of milliseconds. So you would probably not want to use synchronous replication there. Do you have dependencies? So if you were to spin up a service in primary region and passive region, it's most likely than not that you will find some shared service between two. So you would want to find it out earlier and eliminate that shared dependency. So there is increased cost, and not only cost of the infrastructure and total cost of ownership of this infrastructure, but there is also additional operational complexity and observability. So let's take a look at into that. So here is an example architecture of an example company profile. So they operate currently in a single region. They use EKS and a combination of ALB and Aurora and S3 for their data. They would want to improve DR and testing, and they have defined their business recovery objectives as well. So the solution that was chosen was warm standby. So kind of duplicate of the infrastructure. Of course, you have to think about your data replication. So cross-region S3 bucket replication, as well as Aurora global tables. You would also have to think about your DR runbooks in different regions. And also, how do you do failover and making sure that you can fail over and fail back to a region. One interesting service that I would encourage you to check out is called Full Injection Service. and it can introduce chaos testing in your environment. So you can run some experiments and do a network disruption, for example. You can take AZ out of service. You can stop some EC2 instance for some time, etc. So you can do things like this and observe your behavior of your system. And doing things like this and applying those runbooks, you would want to, again, make sure that you're ready for the failover. So something else that can help you here would be, again, application recovery controller. So it has some checks and balances in place to make sure that you can route traffic to standby region successfully. And another interesting part is observability. If your monitoring is in the same region as your application and there is a problem with that stack, your monitoring can go down. Or it might have degraded characteristics. Now you're actually not sure if your metrics are reported are correct or wrong. So in that case, you would want monitoring not only from the region, but from outside the region into your system. And then you'd probably want to have some kind of synchronization heartbeat between different monitoring systems to really understand in what state your system is. Right, so a couple of key takeaways here on multi-region stuff. It's very complex, and the region itself are built in highly resilient manner. So really think about, do you really need this? Just an example, most of AWS services are actually regional services. There are only a few of them that run, let's say, well, single control plane in the console, like things maybe like CloudFront and things like this. But most of the services are regional and they are isolated from each other. So there are hidden costs here. There are a lot of trade-offs. So think carefully, analyze, test, and only then make a final call. Right. So something I kind of alluded to, and it's kind of weird that like halfway through the presentation I'm now introduced to VPC. We talked about like load balancing and cross-zone load balancing, but I actually want to spend just a little bit time that the basic networking constructs is something that is well understood, because I do often see that there are some misconceptions, especially if you come from some kind of on-premises background. Not all things are directly translated into AWS, and it might be hard to digest. So, as I said, we have a region, 3 or more availability zones. Every AZ is its own data center. So the logical constructs that are exposed to you would be Amazon private virtual private cloud or VPC. So VPC is a regional construct, and then inside of a specific AZ you can create subnets. And there are public subnets and there are private subnets. And really the difference between those are two things. Does that subnet has a route to internet gateway or not? That's how it would be considered public. And then in public subnet, you can also assign a public IP address, which would be elastic IP address. So the things in public subnets can communicate with the internet outbound, but it goes and can also accept traffic inbound. And if we want instances in private subnets to access internet, we would need to use NAT gateway or NAT instances, put them in public subnet, and make sure that we route traffic from those instances to NAT gateway, and then not from NAT gateway to internet gateway. Right. Another huge misconception is regarding security groups. And I guess the main reason why is that you don't really do often VM-based firewalling. Most often than not, there are some security controls applied on, let's say, subnet boundary. So the traffic goes to a router, and then between subnets, you have some kind of security policies. But it's very unlikely that there is some kind of like firewall rules applied between, let's say, virtual machines of the same subnet. But that is the case in AWS. So pretty much, well, almost every network interface for EC2 instances and many other services has security group, which is allow lists, and it's also a stateful firewall. So you really need to allow traffic in one direction. So for example, if you want to allow your load balancer, that load balancer to accept traffic from the internet, you configure an inbound rule allowing traffic to port 443, for example. You don't really need to configure reverse rule because it's stateful. One other feature I really like about security groups is that you can cross-reference. So let's say you have a security group on your load balancer layer, and then you have instances. So instead of configuring on instances that you allow access from an IP addresses of load balancer, you can just reference load balancer security group. So not to deal with that overhead of IP addresses. There are many other networking services, which I really try to avoid during this presentation. So just, I will mention a few. So AWS IPAM, there are features for IP address management, shared VPC. If you need to connect different VPCs, you need to think about features like VPC peering, transit gateway, maybe Cloud One. If you need to connect on premises, site-to-site VPN, direct connect. If you have to apply some security policies, maybe AWS Network Firewall, maybe Gateway Load Balancer, Firewall Manager, many different networking services. And one last section is regarding application networking. So there are a couple of services that are listed specifically. One we really talked about a lot during this presentation, which is Elastic Load Balancer. Private Link, this is probably my most favorite service on AWS. VPC Lattice and Verified Access, new additions to, well, relatively new additions to AWS service portfolio. Maria, how are we doing on time?
5 minutes.
Okay.
But if you want more, feel free.
Okay, thank you. Right, so we really talked a lot about application load, Elastic Load Balancing. There are 3 main products: Application Load Balancer, Network Load Balancer, and Gateway Load Balancer. So Application Load Balancer has a lot of features, but it's only for HTTP, HTTPS, and gRPC traffic. We can have like path-based rules, etc. And then on Network Load Balancer, this would be a layer 4 load balancer. So you can have things like TCP and UDP listeners and TLS there as well. Gateway Load Balancer has a specific use case, which is called like bump in the wire, and it's most often used to direct traffic to a third-party firewall instances, like from different firewalling vendors. Okay, I think we will move forward here. So Private Link, this, as I mentioned, this is my most favorite service ever on AWS. And maybe raise your hand if you ever configured VPC endpoints. Okay, some hands, nice. So gateway endpoints are actually not using Private Link, but interface VPC endpoints are. And the idea here is if you have a service and it has a network load balancer in front of it, then in any other VPC in your organization or in another organization, you can actually configure VPC endpoint, which will have an IP address from that VPC, but then it will target that load balancer. So for many VPC endpoints, like AWS services are used the same mechanism as well. So they have network load balancer in front of them, and then you can create SQS VPC endpoint, for example, or S3 interface endpoint. It will target that network load balancer. You can do the same thing with your services. And you can also do the same thing with other services of other SaaS providers or other third parties. So if you or someone else is on AWS and they have a service that you want to access and you want to use, let's say, private IP addresses, some different security posture here, you can ask them to give you this ability to create a VPC endpoint. And it doesn't matter what IP addressing is, like you can have overlap IP addresses, things like this. Pretty amazing service. So it allows you to kind of communicate with other service without really have VPC communication. Right. I think I will cover Lattice because I've seen a lot of interest towards VPC Lattice. So I want to cover that, and I think we'll wrap up here. So let's say you have a number of services, microservices, different VPCs created by different teams. So you would want to, let's say, connect to them, manage load balancing, authentication, and also service discovery. So the common solution to this kind of problem is some type of service mesh. So let's say you deploy a proxy or sidecar proxy along your container, for example, and then you have some kind of control plane which allows to have like some DNS name and to be able to access another service, another proxy of another service and have communication that way. So things like Istio or console, for example. There are some drawbacks or challenges. You actually need those sidecar proxies. So those are additional resources, additional things to manage. Control plane as well for those things. It's mostly for containers. And you actually still need your inter-VPC communication. So that's where VPC Lattice can help you out. So you don't really need any sidecar proxies. You can access it across any compute option. So EC2s, ECS, Lambda. So like whatever your service is, we can use Lattice for it. You have additional security posture. So you can do additional authentication with SigV4 signatures there and have some kind of policies around that. And it's actually pretty simple. Like, again, you don't really need to connect any VPCs together. You can have overlap IP address space. You can have some service uses IPv4, some service uses IPv6. It just doesn't matter. There are many concepts similar to like any load balancer, like listener, rules, target groups. But then there is this logical construct called service. It's kind of a unit of application for VPC Lattice. Then you create a network, which would be a collection of services. And you apply common security authentication policies for that. You have a directory of services. And the idea here is that these two VPCs are really not connected to each other, but we create an interface in a route towards this interface in your source and target VPC with like this kind of IP addresses, 169.254. And then we do some DNS manipulation and say, okay, service1example.com will target this VPC Lattice construct. And then we do this, we will check some security authentication policies, and then this traffic will reappear from this network interface on another side. So pretty interesting stuff. So if you have some time, I do encourage you to check this out. All right. Okay. And as I mentioned, you can apply, there are like some layer 4 security mechanisms, like security groups, but also authentication policies, where you can say, if the traffic comes from, let's say, is uses role XYZ, and you on your client did additional SigV4 signature, let's say you can block or deny based on roles there. It will require some application changes, but the end result is pretty interesting. think I will just mention probably like just one word about verified access, and we'll wrap up. The idea behind verified access is this. So for many years, when we wanted to access our corporate applications, you, let's say, connect to a VPN and then access that application. But like over the recent years, it's like no one wants to connect to VPN to access your corporate services. So the idea here is to like build, have like a managed proxy, which can combine different policies in one place. So when we have let's say VPN, you have your VPN policies on your corp network. You have some identity-based policies in your application, and then you also have device-based policy. Maybe you have some kind of scanner on your machine to search for vulnerabilities, or maybe if you updated the operating system, or like if you're high risk system or not. The idea here is if you connect or combine all of these things into one place and we will manage it for you, it might allow you to deploy those applications without need of VPN access much easier and control those policies in a central place. All right. So key takeaway. So networking is a critical infrastructure component. You really do have to think about like the latency, the packet loss, how many round trips time you're doing, how is your DNS being done, how is your load balancing is being done. There are many fundamental constructs like regions, AZs, VPCs, security groups that you really need to know and understand. Building scalable multi-AZ and even more so multi-region architecture is actually really hard, full of trade-offs. If you can prefer managed regional services, so you don't have to think about these AZ failures, this might help you a lot. And there are so many different various networking services that I encourage you to explore. There are many different use cases there. There are a list of recommended content, but you don't have to like make any photo or that. On the left-hand side, there is QR code for session feedback. So I would greatly appreciate if you could let me know how I did. Once you complete that, there will be a link to those recommended content. So after you submit the service, there will be a link to a PDF with those recommendations. And on the right, there is a quiz from our organizers where you can get some prizes. I would like to thank you all for being a patient audience. I hope you learned something new. I also would like to say thank you to Maria and also to our friends at Philip and Morris. Thank you so much for hosting this event. Thank you.
Do you have any questions?
Thank you for the talk. At the beginning, we talked about the speed of the connectivity and network path. Practically speaking, how much latency do we get as we at the level of the resiliency?
Could you rephrase the question? I'm not sure I understood.
Yeah, when we go multi-AZ or multi-region, we add some number of the hops. And how much latency do we get?
Yeah, so if you want to check, let's say, inter-AZ latency or inter-region latency, you can actually check in your AWS account. There is a service called infrastructure performance. On average, let's say, with the numbers that I saw for, let's say, regions like Frankfurt, for example, between AZs, there will be around 1 millisecond latency. In some other regions, it might vary.
Okay, and if I just want to compare whether I'm getting straight to the EC2, or if I go to the EC2 through the network load balancer, yeah, because I add additional hops, yeah, because I will balance either to one AZ, either to other.
Yeah, so I don't have this data. If you really want to understand the impact on the latency, if you, let's say, use additional components in the past, that's something that you would need to do additional testing. though I haven't noticed in my testing any significant impact on that, especially if you use constructs like network global answer.
So as I see, generally speaking, it's not that much.
Well, it depends on what is much.
Okay.
Something additional I'm thinking about is you also want to understand, let's say, do you decrypt TLS? Where do you do that? Like TLS decryption takes time. If you need to re-encrypt traffic after you do TLS decryption, it takes time. If you have some firewalling, it takes some additional time. And then you have to think about and test it end to end. Is this within acceptable limits for you or not? And if not, then you try to optimize that.
Any more questions? Looks like you were very clear with your message.
Okay, thank you so much.
Right. So now is the time for our quiz questions results, and also for giveaways from our partner for the most active participants.
Okay, so it's done? It's done. We can continue then. But applause to the winners. And by the way, Pavel had to leave earlier, and looks like I am the third availability zone here. So yeah, the resilience is still. Now the hard part. So those of the names and the emails I will read, or at least I will try to read, are the winners of the quiz. So the first one is Martin Pecci. Who is that? Maybe online person. The second is, that's interesting email, inbox.mikhailot. Again, you. That's lucky man. Yeah. And the third one, Federico Nafria. If I'm not mistaken. If I'm mistaken, I'm sorry. Okay, so you will receive the emails with some gift there. Yeah. Yeah, there will be a codes to receive the credits to AWS, not Amazon, AWS, okay? And that's it for today. Thank you very much for coming. Thank you very much to our speakers for interesting talks. And there is still pizza, so you cannot leave without finishing it. And yeah, thank you very much for today, and we will be happy to see you next time.